Okay, so today I'm going to go over the basics of the work energy principle with a quick practice problem. So there's a man in space, and he hits a ball with a force of 2 newtons at a 45-degree angle. After 20 meters, how fast is the ball going if the mass of the ball is half a kilogram, which is about 1 pound, so let's say a cabbage ball. We have to choose our system when calculating work done. We choose the ball because we're looking at the forces that are acting on the ball. If we say chose the ball and the bat, the work done would actually be 0, and we wouldn't really get a whole lot of information out of this. So we start with our basic formula. Work is the change of energy. Well, it also turns out that since the forces are constant, we can calculate work done by the force times this distance here, s. Doing the dot product between these two vectors yields the magnitude of the force, F, times the magnitude of s, times the cosine of the angle. When we input some values, this becomes roughly 28.284 kilogram meters squared per second squared. That's just the first part here. The second part is that the change in energy is also the change in kinetic energy. We know that since the ball is, as you can see, sitting on this little T here, so its kinetic energy is 0 to begin with, so that can be canceled out, and we're just looking at its kinetic energy here. Again, we're looking for speed. That's v2 here, so we don't have a value for that, but we can plug in 1/2 times 5 kilograms. Now down here at the bottom, we can put these two sides together and finally solve for v2, which comes out to be 113.137 meters squared per second squared, which my math here is actually wrong. If my math is correct, it's actually 28,000 miles per hour, which makes sense because the only person that could stand in space and hit a ball would be Superman practicing his swings.